Define kinetic energy and derive the formula for kinetic energy. The answer is like this. The kinetic energy definition. The energy possessed by a body by virtue of its motion is called kinetic energy. So, a moving body will possess a kinetic energy. Energy possessed by a body by virtue of its motion is called kinetic energy. What are the examples of this one? When a bullet is fired and the bullet is possessing kinetic energy, windmills, moving bars, flowing water, rotating wheel, or some of the examples what we see in regular life. We are going to discuss about the examples of kinetic energy. Here you see this cyclist are possessing the kinetic energy because by virtue of motion. In the case of this arrow, when it is released, possessing the velocity, hence getting kinetic energy. And in this case of aeroplane flying, it is possessing velocity, therefore it is having kinetic energy. Even the flying birds are having kinetic energy. And if you see these two last examples, aeroplane and birds are flying and also at a height from the ground. Therefore, they are possessing both potential and kinetic energy. In some competitive examinations, they may ask what type of energy they are possessing. They are not only having kinetic energy, by virtue of position, they are having potential energy also. So that is the importance of this one. In the case of arrow, initially, before releasing, it is having potential energy. And once it is released, it is getting velocity and potential energy is converted to kinetic energy. So these are very critical examples for doing some competitive examinations. Now we are very much interested to derive the equation for kinetic energy. What is the kinetic energy? Energy possessed by a body by virtue of motion. Here, a body of mass m, initially at rest, initial velocity is 0, applied by an external force F, and when force is applied after a displacement S, it acquired a velocity V. And what is the acceleration it attained? A is the acceleration. So consider a body of mass m at rest. When a force F is applied on the body for a time of t seconds, its displacement is S and acquired a velocity V. So when I am writing the data, using the equation v square minus u square is equal to 2as. Here, what is the initial velocity? 0. Therefore, v square is equal to 2as. So what is the acceleration? It is v square by 2s. So the acceleration value is v square by 2s. Here, this is not required. Directly you can write this equation. A is equal to v square by 2s. What is the work done? The formula for work done is equal to F into S. But by Newton's second law, we can write F is equal to ma. Therefore, W is equal to mas. So, we are writing m. Instead of acceleration, this equation I am writing here, it is v square by 2s into s. This s and cancelled. Therefore, it is equal to half mv square. And this work and energy are same. And this energy is by virtue of motion. Hence, it is called kinetic energy. So, work and energy are same. And this energy by virtue of motion. Hence, it is called kinetic energy. Therefore, kinetic energy is equal to half mv square, where m is the mass, v is the final velocity. Hence, the equation for kinetic energy is derived.